Hello everyone, I am Ananya Kumari of MTech IT 5th semester, and in this video I will be solving the second internal question paper of data science, in which we have to fill in the answers in blanks. In the previous video that I uploaded, I solved the third internal question paper, actually not the second internal. That was the mistake. And now let's start solving the paper. So the first question is, the two main paradigms of data research are hypothesis driven and data driven. Obviously, hypothesis driven means first we have a problem or a statement that we need to analyze or make solutions for, and then we have the data with which we can solve certain kind of problems. Big data is often defined by the three V's: volume, variety, and velocity. Big data, which is huge in volume, that comes very fast and should be processed very fast. The type of data science problem that involves predicting a numerical value, such as stock price, is called regression. Okay, so in order to predict a value, we use regression. And for classifying, we have classifiers. The set of all possible outcomes of an experiment is called sample space. Suppose if there is a coin, and if you toss it, what are its possible outcomes, heads or tails? So there are only two outcomes. So a set of these two outcomes will be called sample space, containing the tails and the head. Two events A and B are independent if and only if PAB equals P probability of A and probability of B. So if we have two independent events or probability, then the probability of happening both is equal to the multiplication of the probability of individual events. The median is exact middle value among a data set and is useful for skewed distribution or data with outliers. Obviously, if we have a data with outliers, then for the measure of centrality, we often use median. The correlation value of mean is known relation between two variables. The correlation value tells us about the correlation between two data. If it is fully correlated, the value will be 1, and if it is not, it doesn't have any linear correlation, the value will be 0. Information that is lost during data acquisition and cannot be recovered is called error. No, it's not called artifact, it's called error. I don't know why here artifacts I have written. Maybe I would be confused, but it is error actually. The information which is lost is error, and the systematic problem that arise during data acquisition is artifacts. Now moving towards the next question, which is ninth. The data imputation method that fills in missing data with a value predicted using a method like linear regression, model based imputation. So if we have a data set with missing values, then we get a value predicted by a model and then fills that value in that missing column. Moving towards the next question, which is 10th. Transforming numeric features into categorical ones, such as grouping ages into bins, it is called binning. If we sometimes for algorithms to work, we need to transform numeric features or group numeric features into categories or groups. So for that we use binning. Converting categorical features into vectors is called one-hot encoding. For normal distribution, the rule state that this is empirical rule in which 95% of the data lies within two standard deviation, and 65% within 1, and 99.8% within 99.8% within 3 sigma. The error term E in the model y is equal to fx plus E is composed of the irreducible error and the reducible error also. Yes. Philosophical principle that the simplest explanation is the best explanation. This is a philosophy which is known as Occam razors. This avoids overfitting. If we have a number of ML algorithms that have equal performance, then we should choose the simplest one. In ML, the no free lunch theorem suggests that no single algorithm is better than all others. Hence, we should use a combination of many. On all data sets, yes. Data sets can have diverse effect on different models. Models first make an assumption about the functional form of f. This reduces estimating f to a set of parametric. Parametric models make an assumption about the function form, and this leads to wrong output if the assumption is wrong. So this is parametric. The evaluation metric that measure how often the classifier is correct when it predicts positive is precision, which is true positive divided by true positive plus fake positive. It measures how often we were correct while predicting positive. The resampling method, whether validation consists of only one observation and repeated until all observations have been observed, is called leave one out cross validation. Yes. In this, we if we have n observations, then we leave one as for test, and we train on n minus 1 parts, and we repeat this for n times. So by doing this, we use all the data for test as well as training. This reduces and help us in many other ways. In linear regression, the coefficients are found by minimizing residual sum square, which is the distance between observed point and the predicted point or data. In regularization, the lasso method L1 can force some coefficient to exactly equal to 0, affecting performing and feature selection. Yes, by using the L1 regularization, the coefficients are made equal to 0. However, in L2 we just shrink the coefficients. Moving towards the next slide, which is section B. Here we have almost 10 questions, starting with the first. Create a series. Here we need to write one line Python programs for the question. So let's begin. Create a series named S from a list of numbers data using pandas. So for panda series, we need to use pd.series, which is a function in panda library imported as pd. It creates a one-dimensional array. Calculate the arithmetic mean of a column in df. So for this, we will write the code as given in the respective box. df square bracket single quote a, which is column, dot mean method returns the mean. Calculate the standard deviation of b column in df. Just the same, it's like just the method is different. Dot std returns the standard deviation. Drop all columns rows if df that contains any missing value nan. So here we use drop na method for dropping all the nan all the rows that have nan or any missing value. Fill all the missing value in a column of df with the mean of that column. So first there is df square bracket a quoted, then fill na. All the rows that have na values, the mean of column is filled here. It's a mean imputation. Apply a logarithmic scaling to column A in DF using pandas log. So you can numpy's log. And p dot log, and then in bracket there is df square bracket quote A. Filter the data frame df to only include rows where the value in column A is greater than 10. Here you can see only the rows will be filtered where the column where there is value greater than 10 in column A. Split the data matrix X and target vector Y into training and data set testing sets. So here you can see answer where X train comma X test comma Y train comma Y test is equal to train underscore test underscore split X Y test comma size is equal to 0.2 and random sets is equal to 4.2. It's better to use random sets. Instantiate a linear regression model using object using scikit-learning convention. Model is equal to linear regression. It will be, this line will be enough. Calculate the Pearson correlation coefficient between A and B in DF. So there we have two columns A and B, and we need to calculate the Pearson correlation. So it will be easy just by a given method. First of all, we will select that column df square bracket single quote A dot, then we use method CORR, and in this method we will pass the second column. So here we will get the value of Pearson correlation coefficient. We will tell how much these two columns are correlated linearly. Moving towards the next section, which is section C. Here mathematical questions are given related to probability. So the first is the expected value form. State the formula for expected value of a discrete random variable v over a sample S. So here you can see what formula is given for expected value. Conditional probability. State the formula for the conditional probability in terms of joint and marginal probabilities. Let's again start. There was a mistake that I have corrected now. State the formula for the conditional probability AB in terms of joint and marginal probability. So the answer to this will be probability of A intersection B divided by probability of B. And state the formula for calculating probability of A with respect to B using Bayes theorem. So using Bayes theorem we can calculate this as a probability of B with respect to A into probability of A divided by probability of B. What is, moving towards the next question 34, what is the range of values for a correlation coefficient R? So if it is, its range will be -1 to 1. -1 means the values are not linearly correlated, they're just opposite, and if it is 1 then it is fully correlated. Then 35, what is the expected value for a binomial distribution where the number of trial is equal to n and p is the probability? So expected value will be n into p. What is the variance for a Poisson distribution where with respect to lambda? So variance will be equal to lambda. State the formula for accuracy in classification model using true positive, true negative, false positive and false negative. For calculating accuracy, accuracy is the measure of how often we were correct while predicting all the outcomes. So it's true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. And state the formula for recall in a classification model using true positive and fake negative. Sorry, false negative. So it's the measure of how often we have corrected positive with respect to the total number of positive outcomes. It is true positive divided by true positive plus true negative, fake negative. State the formula for mean squared error for an observation. So formula is given, n1 sigma I is equal to 1n, and it is the difference of a predicted value and observed value, and then we calculate square of it. State the formula for R2 coefficient determination in terms of radial sum square. And so for calculating this, we have the formula 1 minus RSS divided by TSS. So how do we calculate RSS? For calculating RSS, we calculate the sum of the difference of observed value and predicted value, and for TSS we calculate sum of the predicted value and the mean of all the observed values. Moving towards the next question, we have 9 more questions left. So starting with the first one, it is what type of scaling transforms a skewed distribution into a more normal distribution. So if we have skewed distribution, that is a normal distribution with outliers, we have lasso transformation as well as log. We use these kind of transformation to standardize the data. Regularization methods used to improve linear regression model. How does stochastic gradient descendant? So here for this there is lasso and ridge, L1 and L2. L1 makes the coefficient 0 and L2 shrinks the coefficient. L2 is better. So here, what happens to variance of a model as regularization parameter lambda increases? So what kind of method are used in descriptive statistics? So when bias and variance on bias actually increases with regularization and variance decreases. As variance decreases, it performs a little better on training data. What is the main potential risk when using a non-parametric model which makes no assumption about the function form of f? What is the main potential risk when using? Okay, so when a parametric model makes assumptions about a function form, it performs well on the assumed form only. This is what happens in overfitting. Test the model perform well on training data, that is on the similar features it gets while training, but not on the set data or unseen data. What is the main potential risk when using k nearest neighbor? What technique is typically used to find optimal value for k? So for finding the optimal value of k, we can use cross validation. Here as we choose the value of k, we can analyze multiple outputs, and using cross validation with output with minimum error tells us what value of k will be the best for algorithm. And if the value of k is low, bias will be low, variance will be high, and if the value of high, the variance will be low and the bias will be high. So what is the distance metric that calculates the similarity between two non-zero vectors using dot product, where higher values imply more similar vectors? So suppose if we are performing operations related to document similarity, maybe, in which we have a in which we have a metric containing all the words that we get in the document along with its frequency. So in order to make comparison, we use comparison for um, finding if there is a similarity or not. We use cosine similarity method, in which we calculate the dot products of the two methods, and if the cosimilarity value is high, cosine similarity value is high, it tells us that the document is that much similar. If it is low, then it is not similar. In the context of bias variance trade off, a model is suffering from high bias is typically categorized as what kind of fit? Underfitting. So, where there is high bias, which means it will not perform good on training data as well as test data. The model will be simple, so it will suffer from underfitting. The area under the ROC curves for a classifier that performs no better than random guessing in a ROC plot is what numerical value? 0.5. So actually the ROC curve is used for is used for evaluation of a model, prediction, evaluation of the prediction of a model. So area under the curve tells us how much better it does. Lastly, I would like to thank you all for listening to my video with so much patience. Thank you so much.